Scientific notation is used for very large and very small numbers. So if we want to write these down, scientific notation works very well. And there's just a couple of rules that you've got to remember when you use scientific notation. The first one is that it is written as the product, which means multiplication, of a number between 1 and 10. It's very important, between 1 and 10, and then you've got to have a power of 10 in it. And it looks like this. That is your number between 1 and 10. There's your 10 with some sort of power. Alright, so as it says there, A is always between 1 and 10. So if we have a look at the examples below, they're actually asking to identify which of these are actually in scientific notation. And if we have a look at it, this one applies the rule well. That's between 1 and 10. There's your power of 10. There's your 10 with a power of 7, and it's multiplied together. This one doesn't, and you can see why, because that number there is not between 1 and 10. So this one is, this one's not. This one has got a number between 1 and 10, but as you can see here, that is not expressed as a power of 10. This one, well, let's check the rule out. 3, yes, that satisfies between 1 and 10, times 10, power of negative 4, that's fine. The number at the top can be positive or negative, so that's correct. And here, there's just a big number. It isn't expressed in scientific notation at all. Alright, I'll just move this up the page a little bit so we've got some more room. There we go. Now, converting these into scientific notation is just a matter of making sure that we apply the rule correctly and you know what it means to multiply by a power of 10. So, 60,000. We'll write it over here. We start with the number. And we break it into two parts. A number that is between 1 and 10. And then the rest of the number. In this case, it would be 10,000. Because it's 60,000 there. 6 times 10,000 is 60,000. So the last step is just taking my 10,000 and writing it to a power. So if you have a look at there, the number of zeros is 4. And that tells us that that's the case. And you can check that out with your calculator. But there's our solution. Let's do this one a little more speedily. If we've got 7130, we end up with a number between 1 and 10, and we've got to use all the digits. You'll notice 7.13. 0 is not significant when it's in this format. If I take this and I times it by, now look at this, 1, 2, 3 zeros. There's our number. We're actually timesing it by 1,000 because that's 7,000. There's 7, must be 7,000. Then our final answer is 7.13 times 10, 3 zeros to a power of 3. And that's how they're done. What about when you've got small numbers? So these are very big numbers or relatively big numbers. With small numbers, the same rule applies. It's just a matter of deciding how to actually write the power of 10. So if we take the first number, which is a relatively small number, 0.0003, what we've got is our 3 times, now the position, I'll just put a 1 there, of this is in the other side of the decimal, in the decimal part, not the whole number part, and actually its place value is in the 10,000th column. Now remember, that's tenths, hundredths, thousandths, 10 thousandths. And that's what it looks like. So if we write it like this, that would be 10 to the power of 1, 2, 3, 4. And of course, when we write this in index form, without being a fraction, the index becomes a negative. And that's why we write that number with a negative index. It occurs the same here with b. Let's take the number 0.00528. We write the whole number down, so it would be 5.28. Remember, we've got to have a number between 1 and 10, times by, now the position of this number is the thousandth column. Notice it's the 5 that we're looking at. That's the significant number there. That's tenths, hundredths, thousandths. So it's times by 1 over 1,000, or the thousandth position. And then we repeat what we did in example A. 5.28 times 1 over, that would be 10, 3 zeros, so it's to the power of 3. So it's 5.28 times 10 to the minus 3. All right. Now, a next example, it says write a basic numeral for each of these. So we're actually reversing the situation here. So the way you've got to think about this is like this. You take your number, and then you write it out like this. Now, you don't have to do this in the end, but to understand it, we have a number with 1, 2, 3, 4, 5, 6 zeros, because the power of 6 gives us 6 zeros. So we end up with a number like this. It's 4 times this. Now, if we put it here, that's 100, that's a million. So we've got 4 million all up. And there's our solution. So they're the steps that you should be thinking about. In this one here, we've got 5.3 times 10 to the 4. So we'll take our 5.3, we'll multiply it by, now we've got 1 with 4 zeros. 1, 2, 3, 4. So in this case, 5 is multiplied by 10,000, so it would be actually 53,000. And you can tell that that's the right position because you've got 1, 2, 3, 4 zeros, and the decimal place was here, and now it's located 1, 2, 3, 4 places to the right. In C, also a very large number, so we write down 2.96 times 10 to the 5. We've got 2.96 times 10. Now it should be 1 with 5 zeros, so it's 1, 2, 3, 4, 5 zeros, which means our answer will be 296. They will be the main digits in there, and because there are 1, 2, 3, 4, 5 zeros that we're multiplying, the decimal is going to be located not here but 5 places to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's right. So the answer is 296,000. Okay, what about small numbers like this? Well, let's write it down and we'll use the same sort of method as we did in the previous example. Okay, so we've got our 7 times, now in this case we're going to change this to 1 over 10 to the 3 to get rid of the negative index. So that would be the same as 7 times 1 over, so it's 10 would be 1 with 3 zeros. Now, probably the best way to understand this is to convert this to a decimal, 0.001, and our final answer is 0.007. Now that's the reason why scientific notation works. We will show you some quick methods to do this in the next example, but just for now let's follow the reasoning behind why these numbers change and how they work. So you've got 3.6 times 10 to the minus 5. So there's our 3.6 times 1 over 1 with 5 zeros, 1, 2, 3, 4, 5. So that would be 3.6 times, now if we change this to a decimal, we get 0. Now this will be 1, 2, 3, 4, 5. You can just put that in your calculator and it'll work that out for you. And when I multiply 3.6 and that number there together, we get 0.000036. Now it's important to see how this works, not just to use the short methods to do them, but to know why it works, so that when you do use the short method, you've got some understanding of what's happening. So 7.29 times 10 to the minus 4 would be 7.29 times 1 over, now it will be 10 to the 4. We missed that step here, actually dropping it down, first of all changing the index into a positive index, but you can see how it works. So we've got 7.29 times 1 over, that would be 1 with 4 zeros. So we've got 7.29. Changing it to a decimal would be 0.0001. And we'll give a final answer of 0.000729. Now that's a lot of working, but there are quick ways to do it. So we're going to do those right now. So looking at this example here, it says write in scientific notation. Well, let's write our number down. 138,000. So now what we're going to do is we're going to move our decimal point, which is here at the moment, so it's positioned between the first and the second digits. This is always a number between 1 and 10. So in this case we're going to get 1.38, and I'll just put these here for now, 0, 0, 0. So actually we can't use that equal sign because they're not equal, but we're going to go from here to write it out. Notice the point has gone from here to here. Let's count how many places. 1, 2, 3, 4, 5 places. So the number of places that it's moved, or to get back to where it was, it's got to move that many places, 5, to the right. So what we do then is we actually write it down like this: 1.38000 times 10, and we write here the number of places, and because we're moving it to the right, it's a positive 5. Now you do leave off the zeros when you do this because they are actually not significant. So it's 1.38 times 10 to the 5. That's our solution. What about a negative number? Well, we'll do the same thing. We go 0.000486. Now, I would write equal, but they're not going to be equal when I write these out, as you'll see. We're going to write a number 4.86 you'll notice we've got to move the decimal point to a position that gives us a number between 1 and 10. Now you'll notice to get to this location, we've got to move to the left this time. Sorry, to the left. And we're going to go 1, 2, 3, 4 places to the left. So we actually say negative to say we're going to the left. 4 places. So when we write this out, our answer will be 4.86 times 10 to the minus 4. And that's how to do it fairly quickly, and that's how you'll get used to doing it. The reason why I did it longer prior to this was simply for showing working. Now, there are a couple of other examples that we can have a look at. Now, writing these out, using the method that we just did, we'll take our number 4.83 times 10 to the 7. Now, this number here tells us we've got to move to the right 7 places when we have our decimal point located here. So this is what we're going to do. There's 483. We're going to move it 1, 2. Now we've got to put in some zeros to make up the 7. So it's 1, 2, 3, 4, 5, 6, 7. So the decimal ends up here. Let's check it. 1, 2, 3, 4, 5, 6, 7. That's where it's ending up. So our final number is 4, 8, 3, 2, 3, 4, 5 with 5 zeros. 1, 2, 3, 4, 5. All right, what about B? Our negative one. Well, we start with 9.2 times 10 to the minus 6. This time I'm just going to leave my 92. Yeah, we'll call 92 over here because you can see that I've got to move to the left. See, that's negative 6. So we're actually going to move the decimal point 6 places to the left. So here it is. That's 1. So we can see we're going to have 0 holders as well. So let's go. That's 1, 2, 3, 4, 5, 6. Well, we really need to get rid of that equal sign, don't we? And that's probably one of the hardest things, writing these out. Maybe we should write the equal sign at the end. So let's try that again here. We've got to go 6 places. So it's 1, 2, 3, 4, 5, 6, which is fine, but you do have to put an equal sign in there. So there we go. Let's check it out. 1, 2, 3, 4, 5, 6. And there's our solution, or that's how we express it as a normal number from Scientific, where there's a negative power. All right, so what I'd like you to do now is to try to work with your calculators to do these. So we're going to practice a few of these, but then I'd like you to get on and have a go at seeing if you can do these calculations with your calculator. So I'm going to give you the answers to these, just so you can check and see whether you've got the answers right or not. So the first one, A, the answer is going to be 8.4 times 10 to the 16. You might want to write these down so that you can check them. The answer for B is going to be 2.56 times 10 to the 14. Down here for the answer for C, we've got 1.55 times 10 to the 5. Now we're actually rounding this to 3 significant figures. This was a rounded one. And then the last one, D. By the way, make sure you can see why it's rounded to this and that it is 3 significant figures, just to remind yourself of that process. And here's D. The answer is 3.375 times 10 to the 21, which is going to be a huge number. So try those out on your calculator, and if you need support with that, just get in touch and we'll work on those.